Good morning, everybody. I can see the future, and I think you're all going to do very well on the exam because I made it ridiculously easy. All right, hope everybody's doing well this morning. We've got a lot to talk about. We're going to have an extra special long class today. If you're so interested, you can come along for the ride, but I'll talk about the details of that in just a second. Okay, let's do a couple of things here. Let's do this. And I don't think you want me to be looking like this throughout the whole class, so let's put me back in more normal mode. Yes, yes. There I am. Hello. There, that's Santa Monica Pier. Hopefully you'll all have a chance to go there. If not this summer, in the fall. Let's see here. Okay, and we can do some screen sharing to make this a little easier for everybody. There we go. So let's just very quickly talk about the exam as it's coming up. As you know, it's on Tuesday, and I have made the exam. It looks easy to me. I think you're going to do great on it. It is going to cover all the lecture material through today. Now, if you looked at your announcement email yesterday from that iLearn sent out, you do know that I'm going to have this class be a little bit longer to make sure I can cover all the taste perception material I wanted to cover that's from the book. So let's talk a little bit about that right now. So the class will end at 10:50. As usual, in the sense that you are welcome to leave at that point. However, I am going to keep talking to make sure I cover everything that I want to cover in taste. Everything I cover, though, that will be past 10:50 will, in fact, be stuff in the book, right? So it's not new stuff. I'm not presenting something during that extra time that's not already going to be working. I just got a message that the internet's not connected. Hopefully I'm okay. You can let me know if I'm not. Anyway, so I just want to make sure what I do during that is I'm going to be presenting the taste material just so I can clarify things a little bit. I know it helps some of you study if you get the material from the lecture and the book, and I just want to make sure I allow you to do that. It's going to be recorded, of course, so it absolutely will be available to you later today, probably later this morning, so you can watch the videotape of that extra hour or whatever it turns out to be later on. Okay, the exam also covers all the discussion section material through last Monday's sections. Okay, there will be a section this coming Monday, but it will include new material that will actually be tested on the final exam. Also during that session, this coming Monday's session, the TAs have been asked to give you about 15 minutes at the end for you to ask questions about Tuesday's exam. So they will, have the material ready at their disposal, so they can actually look back on the slides and look back on the notes and stuff like that, so they can help clarify anything you need for the exam that's coming on Tuesday. It covers all the book material through chapter 5. Do make sure that you read the book. There are definitely some questions, a handful of questions on the exam that really weren't covered thoroughly, at least, in the lectures or in the discussion sections. And now let's talk a little bit about the exam. So you will be able to take it during any 80-minute period during the day, starting, I guess, midnight, 12:01 on Tuesday morning through that 24-hour period until midnight Tuesday evening. It has to be taken in one sitting, an 80-minute period. It is an open book test in the sense that you can have all your notes there, whatever you want, but be prepared for the exam, because there's, I believe, at least 60 questions. And so if you're having to go through the book and having to go through your notes or the videos or the slides or something like that, it's going to be hard to finish unless you're prepared. But it is open book, and you can refer back to notes if you need to and stuff like that. There's, at least at this point, I don't think there's anything we want to do about proctoring. However, the exam must be taken alone. So what I don't want to occur, this is one of the very few restrictions I have on taking the exam. What I don't want to occur is for folks to actually be on Zoom together trying to work on questions together. It's a really bad idea, first of all, because the questions are going to be presented in a different order for each student in the class, right? So we're going to randomize the presentation order of the questions. So chances are you're not going to necessarily have the questions that the other person has taken. So that we're discouraging it that way, but just the basic honor system. Take the exam alone. It's important. We want to just make sure that you're the person that's learning here, not somebody else in the class. Again, it's such a straightforward exam. It really shouldn't be a problem. As I said, it's open book, so you'll have things available to you. Okay, just a few comments about the review. As I said, the Monday sections will devote some time to allow you to ask some questions. So do come prepared. Do a review before Monday sections, so you're prepared to ask questions. If no one has questions in your discussion section, the TAs will just will end early. So they're not there to do a formal review. They're there to answer your questions. And there are some questions, some practice questions on iLearn. There are in two forms. Some are just the old practice questions we always post, and they'll be available to you. But then I've also posted, because of the kindness of one of your colleagues in class, I've posted some of the poll questions. Those will be taken down for the obvious reason that I won't say out loud, but those will be taken down before the test period begins, so before midnight Monday evening, 12:01 Tuesday morning. Okay, so there will be some practice questions available, but some of those practice questions will be taken down. And then finally, there is no lecture on on Tuesday. There is no lecture on May 5th to allow everyone to take the exam. So you can take it during the class time if you want. We'll give you a break from lecture on Tuesday. Okay, let's see if there are some questions that you folks might have. Hold on just a second. Oh, hold on. Somebody ask a question, because I'm having trouble seeing my questions right now. Oh boy, what is happening here? Somebody ask a question in chat. There we go. Okay, there's chat. Okay. Thank you for asking questions. Okay. Somebody says they are scared of the exam. Don't be scared of the exam. This is such an easy exam. I really, we've talked about the purpose of this course, this particular quarter, and it's not for you to be intimidated by anything that's going on. It's for you to be distracted and engaged by the learning experience. This is the easiest exam I've probably ever given in my life. So it should be, in terms of having open book material, in terms of already seeing very much what a lot of the questions are going to be like, don't worry, you're going to do great. Let's see. In terms of studying, just read through the book, and if as you read through the book, take a note on something. Though Rosenblum didn't mention that in class, and they didn't mention that in discussion section, so let me just make sure I understand that. Okay, so you'll see there's so much overlap between the book and the lecture as well. And in fact, I'll let you know right now, I have decided to take out some of the new material I add since the book was written to make it easier for you. So there's slides I've been taking out so you're not overwhelmed by any new material, to make it that much easier for you. Okay, let's see. What else? How am I? Thank you for asking. I'm doing well. I hope you folks are doing well too. I'm kind of getting used to this, although I'm getting a little stir crazy, as you can imagine. I think we all will. The exam. So I don't know. Again, I'm so sorry about. I've never given an exam like this before. I believe it is given one question at a time, but if we can actually give you the whole exam at once, we will. I do believe, I've heard from other sources that, in fact, you will be able to go back and change your answers to questions you've already answered before. Once it's not one of these exams where once it's the question comes out and you answer that it's already set. I don't believe it's going to have to be like that. I think you'll be able to change your answers. I just don't know if everything is being presented at once. Everything from taste will be on the exam, absolutely. Is today's extra material on the exam? Yes. So this is absolutely the case that what I'm presenting today when I go past the class time, in fact, will be covered on the exam. In fact, the reason I'm going past class time is because I want to make sure I cover it. So go through everything in the chapter on taste. What I'm going to be doing today is just talking about those things to make sure you understand it and you have another way of kind of comprehending it besides the book. I'm not adding extra material by going past the class time. I'm kind of adding extra clarification by going past the class time. That's it. Okay. In theory, you wouldn't even have to watch the extra time if you didn't want to. I'm just making it available for you to clarify any information you might need some clarification on. Let's see. Will there be polls for taste? Actually, not today. Unfortunately, no. All the polls today are on smell. That's okay. I wanted to make sure that I won't have time to stop once I start taste to give a poll question. Have we only gone through smell and hearing? No, we're going through taste too today. So we went through a lot of hearing, a lot of smell, and a little taste. Okay, anything else? Anything else? And I'm having a little trouble. Hold on just a second. Yeah, this is a little tough today. For some reason, Zoom is acting up and I'm not able to see what I'm usually able to see. Any other questions? I'm pretty sure I've answered everything that's been posted here. Yeah, okay. Shoot, why can't I see? Hold on just a second. Let me just try to see if I can do this. Disable hi, chat. This is chat. I apologize for this. I don't know why this isn't happening. Chat. Yeah, okay. I think I'm getting everything. Let me just say one more thing before we start on today's material, and that is on Thursday, when we will have class again after the exam's over, we're going to have a special guest. The Chancellor himself, Chancellor Wilcox, has asked to actually say hi to you. So I got an email a couple of days ago, and they said, we're looking for large classes for the Chancellor to address the students and talk about what's going on campus, and just to kind of reassure you that things are still functioning on campus. And so what I'm going to do for Thursday's class, and I'll send it out an email for this too. So this is the class that's a week from today, is I'm going to change how the Zoom is set up. So he actually will be able to see you, and you'll be able to see him when he comes to class. I think he's just going to come in the beginning of class and talk to you for about 5 minutes or something like that. So as I said, I will remind you of this before the class happens, but so far as we've been going through the course, I have not made your own images visible to each other. I think they might be visible to each other just for Thursday's class. And if I can then shut that off, I will. Just so it's not distracting for anybody, and I don't want to record anybody if they're uncomfortable with that for the videotape. But we have a special situation on Thursday. The Chancellor is going to be here. It's a big deal. So I want to make sure that he can see you and you can see him. Okay? Are there any questions about that? I'll remind you about that on Thursday. But any questions about the Chancellor coming to visit you? Do you have to get dressed up? No, nobody asked that question. Could somebody just say hello on chat? I want to make sure that's working. I'm having a little trouble with Zoom today. Hello. Oh my gosh. Thank you. Oh my gosh. Oh, I feel popular. Okay, let's close this and then start talking about our new material. All right, everybody. So what we've been talking about, is actually a couple of really interesting things here. And it has to do with the idea of pheromones. Now, remember what pheromones are about. The idea, we know this about animals. We know that animals, mice, insects, deer, They are able to communicate through chemical secretions that convey information about things like fear, things like mating, things like menstrual cycle, right? And we talked about in the animal world, we can classify pheromones and their effects as being of two types, the releaser and the primer. A releaser pheromone is a type of pheromone that's going to release like a reflexive reaction in an animal. The one to think about there would be like the ant that smells one of its ant friends being scared and will run like crazy, almost as if it's a reflex and they can't help it, they'll scatter. The other example is the pig, the female pig that smells a male pig when the female pig's in estrus. It will go into a mating stance to kind of facilitate the copulatory behavior of the male. And that's considered a reflexive sort of response. Those are the releaser pheromone types we've been talking about. The primer types are the types that kind of entrain the menstrual cycle. So we know this is absolutely true with mice. We know this is true with insects. They will entrain their reproductive cycles. And in fact, this is something that we've known for a long time. The question, though, is whether these also apply to what seems like there might be pheromone influences for us, for humans. And so we've talked about this a little bit. We talked about this in the context of Martha McClintock's work and possibly the idea that women are entrained with their menstrual cycles, and that might be based on a pheromone sort of communication between them. But what Martha argues, and what other folks that have done research on human pheromones have argued, is that we should consider there being other types, other classes of pheromones that, that are active, at least when it comes to humans, and possibly animals too. But let's keep it with humans. And what we talked about was one type, in addition to releaser and primer, being a signaler type of pheromone. And this would be the type of pheromone that doesn't cause a reflexive behavior or doesn't cause a kind of shift in menstrual cycle through metabolism or the biology between two people, but provides information so that a human can determine something about, say, who he or she is related to, or the gender of a person based on smell. Maybe even the reproductive potential, and we'll talk about that in a second. I mean, in other words, is this person that I'm smelling right now a good potential mate for me? We'll talk about how important that is for humans in just a second, but these would all be examples of signaler pheromones. And you know, we know something about this research. This research is typically done with these T-shirt tests, where people are asked to smell a set of T-shirts and determine from those smells which one is a sibling, which one might be a friend, which one might be a parent or a child, which one smells best and might in fact be of a person that does have a good reproductive fit for you. Okay, those would all be examples of signaler pheromones. Okay, the other type that has been discussed in the context of human beings is modulator pheromones. And these are the sort of pheromones that have a very subtle but, you know, systematic influence over a person's mood and emotional state. And we've talked a little bit about these as well. Okay, again, these are subtle effects. They're not like the releaser effects, but we know that, in fact, if you were to smell the smell of somebody taking an exam, somebody on a roller coaster, it would have a very subtle but measurable effect on things like your startle response and how vigilant you might be on a test, or how you might interpret neutral facial expressions as being more negative than usual. If, again, you're getting this fear-inducing or this fear kind of communicating odor from a person who's been fearful for one reason or another. Okay, so we've started talking about these a little bit, and so these are examples of how how maybe these other type of pheromones might be active for human beings. So let's do a quick review of these. Again, these are completely in the book. You can rewind the tape if you want. But releaser and primer pheromones have been discussed for a long time with regard to animals. Releaser are these kind of reflexive sort of reactions to a pheromone communication, like the pig and the ants running away. Primer are the ones that kind of prime the body to kind of shift their biology so they can entrain for menstrual cycles, that sort of thing. And we know these exist in animals. But folks that study humans think, oh, let's expand our understanding of pheromones and talk about these two other classes. A type of pheromone that signals something, like who you are related to, the gender of a person, potentially the reproductive potential, and we've discussed that in the context of T-shirt tests. And then these other ones, these modulator pheromones that we've already seen a little evidence for, that they can very subtly have effects on mood, like the fear-inducing odor we talked about in the context of somebody being on a roller coaster, providing a sweat sample, and that sample then will, when received by a person unconsciously, will cause them to have a greater blink response, startle response, and maybe interpret faces differently or change their vigilance on a test. Okay, so that's great. That gives us a nice framework to now go ahead and talk about the rest of the evidence that there might be pheromones working for human beings. So that's the point of the top of the slide here. And now we're going to organize the final discussion of pheromones and scent, for that matter, by these concepts. Okay, you'll get it as we go along. Nothing too technical about it. I just want to make sure you understand why we're doing what we're doing right now. So, for example, let's think about some other signaler pheromone effects. We'll do a little review. Remember, we just talked about the fact that when you're smelling a T-shirt, you could smell your kin, you can smell gender, you can smell your friends possibly. But we also started talking about this really provocative idea that when you smell somebody's scent signature, what you might be smelling is something to do with their major histocompatibility complex, which is shown right here. This is just if you're interested in how it's kind of typically portrayed on the genome. It's something like this. I don't get it either, but that's the idea. And the this compatibility might signal something about how complementary immune systems are to each other. Okay, let's make sure we understand that. What does it mean to have a complementary immune system? Well, the idea is this, that biology, as as animals are picking their reproductive mate, would want to find a mate that has an immune system that kind of fills in the holes that one has in their own immune system. Okay, so say I have an immune system that's not really good with a certain type of virus, for example. If I could find somebody to have an offspring with that did have a good immunity to that type of disease, okay, that would benefit our offspring. So this is what I mean by complementary immune systems. Here's my immune system, here's my wife's immune system, and if they fit together well, look at that strength that our offspring will have. They complement each other. So it would benefit me to find a mate, to find a wife that has a complementary immune system. It would make our children stronger in terms of their immune system. And because this MHC is coding for immune system, and because it also helps determine the scent signature, if in fact I can choose a mate partly on how they smell, I could choose a mate that will have a complementary immune system, allowing us to have offspring that have a stronger immune system. Does that make sense? Now, I've given the example of me and my wife because I thought it would be intuitive to you. The evidence that this is something that is driving mate selection in people is not that strong. Where you do find it strong is certainly in mice and birds and fish and lizards. You find that mice, for example, we'll stick with mice, will choose mates who have complementary immune systems so that they have baby mice that are healthy and can ward off disease. And the communication for that complementary immune system is something that comes through smell. So this idea that what you're smelling in a scent signature is something about another individual's, whether it's a mouse or a person, at least for mice, seems to hold, okay? And also for birds, fish, and lizards. So that's really provocative. That's a really cool idea, and it's one of those great examples where, boy, nature is clever, right? Nature wants animals to find mates that will provide strong offspring, strong babies that will resist disease, and isn't this a cool way to do it, right? It finds these MHC systems that are complementary, and how do we signal that? Well, in animals, we can signal that through scent. Hey, I'm a good match with you because we match well together because of our complementary immune systems. Cool. That works with mice, birds, fish, lizards. If you look at the ones that mate together, it does show that type of thing. What about people? Because think about this. This is profound, right? So, maybe some of you are in heterosexual relationships right now, and you're thinking, boy, did I choose my mate not on how attractive visibly they are, and not how much we have in common in terms of our intellectual interests and our sense of humor, and whether or not we like scary movies, right? That might be the reason you thought, but maybe the whole time what's really happening here is our MHC is telling each other it's compatible through smell, and that's how we've selected our mates. So you can understand, like the ramifications for this type of thing can get pretty dramatic. In fact, there is I believe it still exists. There is a system. There's some sort of company online where you can send a sample of your saliva and your mate's saliva, and they'll do an analysis to determine how compatible your MHC is, and whether or not, therefore, you should, think about having healthy offspring. Well, the truth is, it doesn't seem to be as driving for people as it does for animals. So I wouldn't go out and do that. But there is some really interesting evidence that it might play a small role. I think you're going to find this really interesting. So for MHC in humans, in fact, as you've learned, those t-shirt tests do suggest that when we are kind of objectively smelling t-shirts of an opposite gendered person, the one that we will find, and this is especially true with women subjects, by the way, the one that a woman will find most attractive in a set of 10, if she doesn't know any of these 10 people, is in fact the person who will have the most complementary MHC to their own, okay? So in kind of objectively choosing a mate's smell or a potential mate's smell, it does seem to have an influence, okay? It does seem to have an influence. Okay, that is true. However, what is not true is if you look at married couples, you would expect to see potentially that those married couples would have complementary MHC, and that would be something like you see in mice and in lizards and birds and fish that you'd also see in people. There is not strong evidence for that. So there doesn't seem to be a lot of evidence that, at least when it ultimately comes to picking a mate, that MHC is kind of overriding. Okay, you don't see that really becoming an important factor. So your intuition that I did choose my mate based on their visible appearance and based on the common values we have, the common interests we have, that does probably, your intuitions there are probably correct. But there's still some other evidence that MHC does play a role. And people find this fascinating. So I think I'm going to stop after I do this slide because I know you're going to have a lot of questions. When it comes to MHC compatibility, it doesn't necessarily predict who your ultimate mate is, your ultimate spouse, the one you have children with. But at least for young people, it does have some predictive power for things like a woman's extramarital affair or extra relationship affair and fantasies. So this is the evidence, and actually, I haven't completely kept up. This is controversial to some degree. When I wrote the book, this was certainly something that was more or less accepted. I should see if it still is. But let's go with the book. If a young woman is in a relationship with a man who has less compatible MHC to their own, less complementary MHC to their own. In other words, there's too much overlap. When I say less complementary, I mean there's too much overlap. They are more likely to either have fantasies about other men or, in fact, act on those fantasies and have extra relationship sort of affairs. You know, they have affairs with other men. Now, this is research that's been done on probably undergraduates, you know, maybe up through their mid-20s, and them and their mate had their MHC tested, and, you know, without giving them the results, they then also asked, you know, kind of anonymous questions about the woman's, you know, status in the relationship. And what you find is that the more their MHC is similar, not complementary, but similar, not filling in those holes, the more likely they are to have fantasies of other men and to have extra relationship affairs. Okay. Again, this is not necessarily going to be what's going to select your mate ultimately, but the fact that it can have what seems to be a subtle behavioral, I guess, cause. Let's be, I guess, a small kind of influence over fantasies and extra relationship affairs is interesting. That tends to, by the way, increase while a woman is ovulating. Okay, that does increase during that part of the woman's cycle. Okay, it increases during that part of the women's cycle, which is interesting. So if she's going to have fantasies about other men, if the MHC isn't complementary, it's more likely to be during ovulation. And we don't know this for certain. We only know kind of the relationship between MHC compatibility or complementarity and you know, fantasies and extra relationship affairs. But the inference is this might have something to do with subliminal odor, that this communication about the MHC when it comes to how it might influence extra relationship affairs and fantasies, especially during ovulation, could be based on subliminal odor. Now, I know this is probably blowing some of your minds to think, oh my gosh, all this time, maybe this is, you know, I've always questioned my relationship. Maybe this is the reason. I'm gonna make sure we're very clear on this. These are very subtle influences. So much goes into your choice of a mate and your kind of the, you know, the degree to which you're fantasizing about other people, or the degree to which you're you know, having affairs outside your relationship. Then just this, the fact that it has any influence at all, is interesting. So let's go ahead and talk about this. Oh, shoot. Hold on just a second. Oh, I'm sorry. What did I do here? Okay, so I'm going to stop sharing. There we go. Okay, very nice. This is all making much more sense now. Hold on. I am going to take some questions from you folks because I bet you're wondering what the heck is going on here. So let's do that. There's the chat. Okay, everything's good. All right, here we go. Let's start. Thomas wants me to be Baby Yoda. I will be Baby Yoda eventually when the spirit so moves me. Okay. Does Aida asks, does being familiar with someone affect your pheromones? Given pheromones in the book, it is not only a reason for fertility and compatibility. I'm having trouble kind of reading this, Aida, but let me see if I can answer. Does being familiar with someone affect your pheromones? Yeah, it might. Well, I shouldn't say that does it affect what's secreted? I actually don't know the answer to that, but it affects how pheromones might have an influence on you. That I can say. Given pheromones in the book, it is not only a reason for fertility and compatibility. It's certainly, okay, so if you're asking, are pheromones the sort of thing that really, really direct, are they the prime kind of cause over mating and that sort of thing? Absolutely not. If you read ahead in the book, you know the title of this chapter is Marvin Gaye for Your Nose. And the reason I chose that title, you'll understand more of this in just a second, but Marvin Gaye is the sort of thing in my generation we used to play, music we used to play to kind of, you know, set the mood for a romantic situation. And I think that's the job of pheromones too. So no, if you don't want to, if you're with somebody and they put on Marvin Gaye music and you're really not attracted to them, it's not going to make a difference. Say, I love Marvin Gaye, I love the candlelight, I love the food that you just made me, but I just want to be friends, right? It's not going to be controlling. It's going to have subtle influences. So hopefully that addresses that question. Lisa asks, I remember reading that we find accents attractive for a familiar reason because they signal a different gene pool than ours. That's a really, really good point, and you're absolutely right. It's not that relevant to scent, but it's a great question because we will be addressing accent and imitation of accent later on, which is going to be very relevant to this. Sometimes your video audio pauses for a second. Okay, I am in fact getting messages today about the internet. So I will see if there's anything I can do about that. If it happens a lot more, I will, I don't know, figure out a way of maybe getting closer to our emitter or something like that. Do we know if a woman can be classically conditioned by MHC? For example, could they be exposed to attractive dudes with a type of MHC and that would lead them to be attracted to them, even if it's not? Wow, that's a really interesting question, Benjamin. So to the degree we understand it, MHC is something that's completely biologically based. Now, can you be classically conditioned to like a scent? Yes, and I'm sure that happens, right? So, when you date somebody who has a specific perfume, a specific cologne, you do in fact, find that attractive and maybe even arousing after a time because we've associated them with the, and our romantic relationship with them with the scent. I don't think, as much as I understand it, that has as much of an influence, if any influence, over our scent signatures as such. I don't think that's the case. I think it has to do with kind of the superimposed sense that we place on each other. Okay. Okay. Can I define what a primer and releaser pheromone is again? Nicole asks. Okay, just very quickly, Nicole. I've gone through this a number of times, but it is on the videotape. But what a primer pheromone does is it's going to kind of set the body into kind of a certain metabolism, certain biology. So it kind of shifts things like menstrual cycle and possibly other things, but we've talked about that in the context of menstrual cycle. And a releaser pheromone is the sort of reflexive reaction we have to pheromone influence, like the ant scattering and the pig mating stance. Okay, I know you did MHC studies about women extramarital, but does it have the same effect on? Yeah, very good question, Natalie. Thank you for asking that. In fact, most of what we'll be talking about today. Oh, there's a roller coaster that's getting people scared for that study. Cool, I just noticed this. Sorry, distracted. Most of what we'll be talking about today is studies that have used females as the receivers of the smell. And it does, in fact, seem to be something that has more of an effect on women. There is some lighter evidence that these things can have an effect on men too, but I think the more consistent evidence is that everything we've talked about with regard to pheromones does have a stronger effect on women for some reason. Okay. Don't worry, slight pauses. Okay. I'm not sure what else we can do, but I'll think about that. And then Samantha has a question. Do you think we learn to like our significant other's scent? She has a little anecdote here. Thank you. For example, my first boyfriend I was with 4 years and we were in love. I now love that scent and prefer anyone who smells similar to that scent. And you think that's their natural scent. That's really interesting. I mean, it really could be that if that is their natural scent, again, a lot of things go into play when it comes to the conscious scent that we're able to pick up. So you'll read in the book, I don't think this is something I lecture on, but you'll read in the book that individuals who have a vegetarian versus a carnivorous diet, whether they or not they eat meat, will have an influence on their scent, and that's their conscious scent. What we're really talking about now is unconscious scent to some degree. I mean, clearly these T-shirt studies show that you can kind of be pushed into an ability to smell things that are more subtle in a scent signature. But what typically occurs in our conscious ability probably comes down more to things like perfume and soaps and things like that kind of override it. So certainly we can be kind of conditioned on these kind of more conscious scents. Whether we can be conditioned for a specific kind of MHC-based sense signature? I'm not sure. I really don't know the answer to that. It's a very, very good question. I heard that if your partner smells after the gym, you'll be less likely to perceive them as stinky. Oh, than you would somebody, yeah, because you're maybe just familiarized with their bacterial scent, which is different from their scent signature to some degree. Great questions, and I know we always get some really interesting questions about this topic. I think it's a really interesting topic. The book goes into more detail. I recommend that you look at that if you're interested. Okay, let's do a poll. Okay, this will give me a little chance to have a sip of water. How's that sound? Okay, yeah, let's do this one right here on sibling scent. So I will read the question off, and then I will give you a chance to answer it. What is true of our ability to recognize people through their natural sense? A, we recognize our siblings better than friends. B, we recognize friends better than our siblings. C, we recognize friends and siblings equally well. Or D, we can't recognize anyone just by their scent. I think this is a very straightforward one. Let's see how you do. Okay. You're doing great. So just so you know, that was 30 seconds to answer the question, but you'll have more than that, certainly for each of the questions on your exam, so you'll have no problem with that. And most of you are getting this right. Okay, I think we can stop it there to make sure we get everything in today. So I believe almost everybody, well, 85% or so. The correct answer is A, we recognize our siblings better than our friends. And remember, I think I even said that today, but certainly I said that last class, that when we are smelling t-shirts, even if we've lived with somebody for a longer period, so I certainly have, now lived with my wife longer than I lived with my brother, I would still be able to recognize my brother's scent more easily than I would recognize my wife's in this case, which is really kind of counterintuitive in some ways, but it seems to be true that the kind of biological commonality, the biological connection between you and your siblings kind of is greater when it comes to scent recognition than it does your friends, your spouses, even step siblings and that sort of thing. So the biology plays a really strong role here. So the answer is correctly A for you, 84% of the people. We don't recognize our friends better than siblings. We don't recognize them equally well. And we know that you can certainly recognize people from that. Okay. Benjamin, some other people ask questions very quickly. Does subliminal smell pheromone really affect one's attraction to each other when their code is dissimilar? So yeah, so the Aida is asking, subliminal smell of pheromone really affect one's attraction to each other when their MHC code is dissimilar. Just make sure we understand this. This is an important point when it comes to the complementary thing. Sometimes people get a little confused about this. What you want, what biology wants, and it certainly is the case with mice, for example, is a complementary relationship between the two immune systems. Okay, so here's my immune system. I'm a mouse. Let's make Rosenblum the mouse, and of course I married a mouse. So my mouse wife's immune system optimally would be something that fills in the holes of my immune system and vice versa. These are complementary. These are compatible immune systems and therefore compatible MHCs. What you don't want is, my MHC to be, very, very overlapping with hers, in which case, they're the same and they leave these holes here. In fact, that, in families where there's a lot of intermarriage, that causes, offspring problems, genetic problems in offspring. You don't want them to be too similar in the case of MHC as well. So you want complementary, you want them compatible, you don't want them similar. Okay. And then Benjamin asked another question. In our scent recognition of siblings based on our exposure to them or the fact that they are related? It is the fact that they are related. So in fact, if you have a twin, doesn't even have to be identical twin, but if you have a twin separated at birth, you will ultimately, and then you get their T-shirt later on, you will say either this is my T-shirt or this smells very, very familiar to me. And if you're told you actually have a sibling that was separated at birth, you say, oh, that must be their smell. So it is not the amount of experience when it comes to sibling scent. It is the biology. Experience can play a little role, but biology is the answer there, okay? Someone has a hot mic. Oh, okay, thank you, Natalie. So I believe I've muted everybody, but sometimes Zoom acts a little crazy, but I think we're okay to move on. Okay. Good. Let's continue talking about this and make my picture big. Oh, shoot, man. Okay, sorry, everybody. Let's take a second. There you go. Okay. Yeah, someone does have a hot mic. I'm not sure, but just want to make sure that you're muted. Okay. Let's continue talking about this. And again, what we're doing here is we're continuing our discussion of what might be signaled by smell, what smell actually might be telling us about somebody. And we've already learned that can tell us something about who the person is through kin and possibly to some degree our friends and our siblings and that sort of thing. We can do that, but better with kin, as you now know for certain. But then also the potential for compatibility in terms of immune systems as coded through MHC. But here's something else, symmetry. What is meant by symmetry? Symmetry is a very simple concept that really just has to do with if you were to kind of draw a line straight through somebody's body, does their left side look like their right side? Now, we all have little asymmetric things, right? Maybe you have a birthmark, on one side of your face rather than the other. But overall, is the overall structure of your right side similar to your left side, okay? You can see some face right there. I think that's a nice example of a face that's not particularly symmetrical. And this is also true of animals. You'll see, hooves of different sizes across the body. Usually, again, this is symmetry that's defined vertically like this. And why do we care about that? Well, because symmetry turns out to be something that is predictive of health. So this is what we know about symmetric animals and, at least to some degree, symmetric people. Low body symmetry in animals, if in other words, one side of their body is very different from the other side of their body, typically noticeably different from the other side of their body, like in this case, this is why I have this up here. It's two hooves that look of a different shape, okay? That it tells us something about it. It tells us that that animal is going to have slower growth and probably not live as long as an animal that has better body symmetry, and probably won't be that fertile either. The likelihood is that they will not produce as many offspring or live long enough to produce many offspring. So an asymmetry in an animal, whether it's a horse or a deer or a mouse or something like that, typically indicates less health, okay? Now, what about us? And much of this research on body symmetry is done on faces. And so it's interesting. Just a second. It's interesting that if you want to find a group of faces of people who are not symmetric, like this poor gentleman right here, if you look for that on the internet, what you'll end up seeing often is prison lineups, suspect lineups. Okay, there might be a reason for that, actually. But what you find is with somebody who has a low facial symmetry, and we're talking about major, I mean, this is pretty clear here with this guy here. We're talking about pretty major differences. Again, you look in the mirror, everyone's kind of looking at their mirror now at home and saying, God, do I have one of these faces? Chances are you don't, even if you have, like blemishes or something like that. Your face is probably pretty symmetric. But for individuals who have low symmetry, you do find some interesting patterns. Typically, their IQ is lower. and they have lower physical and mental health. Again, we're talking about big differences here in symmetry, not just, I got a little scar over here when I was little, and therefore my face isn't symmetrical. We're talking about, kind of an asymmetry in kind of the bone structure and things like that. And individuals who have more asymmetry typically have lower IQ, worse physical and mental health. People, on the other hand, that have high body symmetry, and this is often, again, evaluated with faces, tend to have more sexual partners, and there's research on this. Men that are rated to have higher facial and body symmetry are able, I guess, to give women more copulatory orgasms. Okay, this is the research. For whatever reason, and this is, you can understand, this is done independently with a group of subjects that looks at a whole bunch of pictures of men and rates their symmetry, and then the experimenters come out and say, yep, looks like this one's symmetrical, this one's not symmetrical. And then all these men are also doing questionnaires about their love lives, and then they have their mates come in and do questionnaires of their love lives. And what you find is the more symmetric a face and body is in a man, the more copulatory orgasms their female mate will have, okay? They'll also have more sexual partners, all that sort of stuff. Okay, what does this have to do with anything? Well, it's likely that symmetry does signal health. It looks like it signals, as we said, physical health and mental health, okay? So that's one of the ways we're able to look at each other and tell something about how good a partner might be in terms of having healthy offspring, as an example, right? Interesting, and something we'll talk about later on when we discuss face perception and attractiveness and all that sort of stuff. What's this have to do with smell? It seems like when women are in their fertile phase, that they like the smell of a symmetric man's t-shirt better. Okay, so again, it's a great t-shirt study where you have men of all types of facial symmetry, including this poor little gentleman right here with low facial symmetry, wear a t-shirt. They then donate the t-shirt. That's their natural scent. You have the women now rate the t-shirts in terms of their attractiveness. And, as we know, MHC will play a role in that, but that's not the only thing. They'll say, oh, these 5 are more attractive than these 5, and the 5 that they'll choose, okay, will be the same that other women will choose to some degree at least, and those will be men that have more symmetric bodies and faces than the other ones, okay? So in a sense, symmetry is something that can be smelled, right? Man's symmetry is something that can be smelled. Clearly, what is being smelled here is something beyond the visible symmetry, but there's this kind of relationship, this correlation, which is just really fascinating. And what it suggests is that what we're smelling, what a woman is smelling in these cases, is a man's genetic health. And genetic health and potential for healthy offspring isn't just something that has to do with MHC compatibility. It has to do with the health of the male mate one is potentially selecting. And that's reflected not only in smell, it's reflected in the symmetry of an individual, their visible symmetry, okay? And so that's what I mean, that you know the smell of symmetry. Visible symmetry, whether a man looks symmetric, like this guy doesn't, unfortunately, signals something about their health, both physical and mental health potentially. And so does smell, okay? And so you do find this really kind of cool relationship between the visible symmetry of a man and how attractive they smell to a woman. Again, with everything else removed except for the smell, okay, the t-shirts, and except for, these stranger images you're seeing, people you don't know, and their visible symmetry, which is really interesting. Not only does that occur for women judging men, but for when women are in their ovulatory period, when they're in their, when they're in estrus, it actually allows them to kind of more consistently judge the potential symmetry of a person, a man, through smell, Okay, so that heightens it. And why do we make a point of that? Well, the question is whether or not this has some sort of kind of evolutionary basis, whether it has some sort of kind of deep biological basis. And you would expect that if this has to do with mate selection, if the smell of a symmetric man is attractive and is signaling something about the health of the man and the potential offspring, then this might be heightened when it comes time to make a baby. And it does for women. It seems to be a more sensitive sort of thing. Okay, I just got a message that my connection is unstable, but these seem to be few and far between. I assume it's okay. All right. Other interesting things happen with fertility and ovulation when it comes to women. Not only does a woman like a man's smell that is symmetric more when they are ovulating, there's other things that happen as well. A fertile woman will like the smell of a more dominant man better. Okay, so when through every other period of their cycle, when if there's a whole bunch of T-shirts here and they're chosen because they are all MHC compatible and they are all from symmetric men, okay. If it's any other time in the cycle, a woman will go through and say, "Oh, these are all attractive men. I'd date any of these T-shirts." Right? However, if they're in their fertile phase, they'll say, "Yeah, I'm telling a little bit of a difference here. I like this T-shirt the best. They're all nice smelling guys, but this is the guy I wanna be with." Okay. If you then do an evaluation of kind of the personality characteristics of those men, it turns out during the fertile phase, a woman will like the smell of the dominant man better. Okay, I know this is okay. People are gonna start writing letters to me saying, "Well, what does this mean? Are we really going for the whatchamacallit, the dominant male, in the pack, the alpha male, right? The alpha male in the pack. Can we really smell alpha men?" It's a subtle thing, but it is something you can see in the data. But this only happens in the fertile phase, and that doesn't mean like during the fertile phase that a woman's gonna drop her boyfriend because she found an alpha male, the guy's boss or something like that. It doesn't happen like that with people. Don't worry, okay? But when it comes to T-shirt smelling, at least when it comes to kind of being kind of pushed into having to select the attractiveness of a smell, you do see that sort of trend, okay? Which I think is really, really interesting. It's not dominating selection, it's not dominating behavior, but it dominates preference, or it influences preference a little bit. Okay, we got the question before, like, is this all having to do with how women smell men, or can it work other ways? Well, as it turns out, it can. There's less research, or there's less, I guess, conclusive research on whether men are sensitive to these types of things in women. Also, I get this question often. I don't think there's a lot of research on homosexual couples or homosexual individuals. Most of this research is on heterosexuals, or at least people in heterosexual relationships. So I'm unaware of that type of thing. But there are some examples of research showing that men have preferences for women's smells in a certain way. Specifically, it is that men like the smell of fertile women better. So now you're a man in an experiment, you're getting all these T-shirts, and these T-shirts are from maybe even the same woman. Okay, so you say you get 4 T-shirts, and it is from the same woman, but they are taken from different weeks during her cycle, including the fertile one during ovulation. Okay, and the question is the man going to have a preference, even though these 4 T-shirts are all from the same woman? And the answer is, at least in many cases, yes. They will like the smell of the woman best when she is going through her ovulatory phase. Okay, which suggests something really interesting, because historically, the research has suggested that unlike other animals, humans don't kind of overtly signal fertility. Right, so this about other animals, right? You know this about this little monkey right here, that they signal fertility by kind of changing color on parts of their bodies, and this is true of other animals as well. It's like, okay, it's time for romance. When something changes color on their body, they signal fertility pretty overtly. But we don't think of people as doing this. We don't think of women as advertising that type of thing, although you'll see later on there might be some other things that go on as well. However, there's at least some information through possibly this signaling type of pheromone that has women kind of very subtly telling men when they're fertile, when she's fertile, based on smell. So what we say here is that, unlike what we used to think, we're now starting to believe that it's not something that's concealed in people. Fertility is not concealed in humans, okay? Which I think is really interesting. Let's continue talking about this. I want to make sure we can get through as much as possible. So what we've been talking about so far are signaler pheromones. And in addition to the kind of the primer and the reflexive sort of pheromones, or not reflexive, whatever the other type is. Shoot, sorry, I just lost the word. Yeah, releaser, sorry. In addition to the primer and releaser pheromones that we've established for animals, now people are saying maybe we should think about these signaler pheromones, which you've just seen a couple of slides of, and yeah, it looks like MHC is something that's signaled, and maybe even reproductive genetic health is signaled through this symmetry correspondence thing. That's really cool. But what about this other stuff? What about this modulator pheromone? Remember what a modulator pheromone is? It's a class of pheromones that's going to have subtle effects on things like mood and fear and stuff like that. And we already saw one example of this, right? We saw the eye blink thing, right? The eye blink sort of response. And remember, this is a very clear example of how the smell of a scared individual can actually amplify a response that's typically happening. We're going to have a question on this, a poll question on just a second. So I won't go too far into that, but you remember that whole story. However, there's other things that go on. And this has to do with what we consider might be a pheromone in a person, in a man. So this is what I'm saying here is putative, just meaning that we think that if there is a pheromone communication in people, that this might be it. So the putative pheromone compound in men, if it's presented to women, and it's presented in such a way that they are unconscious of it, okay, it's undetected, it does have subtle influences on a woman's biology and mood, okay? So a woman's sitting there, there's a nasal cannula, she's getting the oxygen, but she doesn't smell anything consciously. But then what's done is different tests are taken. She's hooked up to little devices like an oximeter and pulse and all that sort of stuff. And what you do is you find a very small influence on heart rate. It speeds her heart rate a little bit. It makes her sweat just a tiny bit more, and that's something you would necessarily notice. It increases cortisol levels that you can measure, through saliva. And it does increase mood just a tiny bit. So if a woman is actually being administered the smell of a man at an undetectable level, you do find subtle increases in heart rate, sweat, okay, cortisol levels, all of which are very subtle and wouldn't be noticed, and mood. They might rate their mood as a little bit more positive. Again, I need to emphasize these are all minor changes, but they are systematic changes, and they're interesting because these are changes that the woman isn't aware of themselves necessarily, except maybe the mood, but they aren't aware that these things are being influenced by the presentation of a male pheromone because they don't even know that there's a smell coming through the cannula, which is interesting. What else might it do? Well, if the woman is, watching her favorite romantic movie or favorite, sexual movie, whatever that might be, it does tend to increase the self-reported level of arousal. So, it's kind of a little bit of a awkward experiment, but the woman comes in and they ask, okay, what type of movies do you like to watch to put you in the mood? And she says, oh, I love The Notebook, right? That's a popular one, right? And whenever I watch The Notebook, I'm in the mood. And so they put on the notebook and they, play the romantic scenes. And, she typically gets a little aroused during that time. Her arousal will be a tiny, tiny bit more if during that time in the lab, she's being presented the smell undetectable of a man. It's a little bit of an increase in an arousing reaction to an arousing film clip. But, and here's the big kind of cautionary statement here. These are small changes and possibly not much more than the sort of changes that occur when other things are done. So with romantic music or lighting, and that's why I put this image there. I forgot why I put this image there a couple of years ago. That's kind of the quintessential bachelor pad, right? That's the quintessential bachelor pad where, in the old days, in the 70s, adult men would have circular beds or water beds, and they'd have a button they'd push. Remember, Austin Powers had these sort of things. They'd have a button they'd push, and all the lights would go down, and the music would come up, and all that sort of stuff. And the idea was there to put the woman in the mood for romance, right? And it might. And that's how to think about the influence of whatever this pheromone is doing. It's not controlling you, right? It's not controlling the woman. It's not like, being given a pheromone is going to make a woman find a man irresistible. It's not going to put them in a little bit more of a mood. So, I imagine that if you're watching The Notebook and, it typically does make you happy, that if you turn down the lights or you put on candles or, maybe you lit incense or something like that, it also might elevate your feelings of romance a little bit. That's the idea with pheromones, okay? That's why, and here he is right here. Here's our friend Marvin Gaye. I don't know the type of music you guys listen to be put in the mood, but this is what my generation used to listen to, the wonderful Marvin Gaye. It's the same sort of thing. It puts you, kind of elevates the mood just a tiny bit. That being said, there's other things that pheromones might do that have nothing to do with arousal or any of these things, and not even necessarily mating. Because what you find is that there are other types of smells that can arouse sexual fantasies a tiny bit that aren't from a man. This is really interesting. So if a woman is getting the smell of a nursing woman, I can't remember, she herself might need to be nursing. So a woman who's had a child and is going through a nursing, period of 6 months or whatever, or a year nursing their child, if she is exposed to other women nursing, it has the same effect. Again, everything's the same. It's going through a nasal cannula. It's undetectable, but it's the same sort of thing. And it's known to do things potentially like this is known to be the case for mice. It's known to be the case for deer, that nursing smells from other females that are going through a nursing phase can increase sexual fantasies a little, or not sexual fantasies, but sexual behavior a little bit, that sort of thing. And what it might do, at least in other animals, is kind of coordinate pregnancy and nursing together. And it's thought that for animals, what this might do is actually be a protective sort of mechanism. Okay, it might increase the potential for the animals to be protected together if they're nursing together. This might be something that affects us, but just a little bit. Okay, all right, how are we doing here? Okay, so I think what I'm going to do very quickly, I know I have to stop class in 10 minutes. I'm going to finish my discussion on scent, and then we're going to stop class for a second, go through a poll and answer any questions, and then I'll start taste. All right. So here's the big story. All right. The effects of subliminal odors are subtle and complex, and this is especially true with human pheromones. So if you go online now, you can probably find sites that are selling what are synthetic human pheromones, saying that this will make you irresistible to the men or women you want to meet, right? There is no evidence that pheromones can do that by any means, right? It is a much more subtle sort of influence than that. The best evidence is for singular, especially in human pheromones. The best evidence so far is for signalar and modulator pheromones. The signalar pheromones are the ones that might communicate fear, but also might communicate MHC and bodily symmetry. Modulator, it does elevate women's heart rates and cortisol levels and things like that, and sexual mood a tiny bit. There is some evidence from humans for a primer pheromone with regard to menstrual entrainment, and a little bit for a releaser, a little bit with regard to fear, but those seem to be much more prominent in animals. But what about that? I mean, that's something we've been saying throughout all this. Okay, that is it the case that animals, when they're affected by pheromones, act reflexively? And as it turns out, the story, even at that level, might be more complex. Because going back and looking at that pig research, remember the pig mating stance research, suggests that maybe the idea of a reflexive sort of, I can't help but run away when I smell another ant's fear, I can't help but go into the mating stance when I smell a male pig, right? All these things, they might not truly exist either. Because as it turns out, that pig mating stance is dependent on more than smell. The pig also needs to have something else, at least one other thing. It can't just get the smell and go into its mating stance. It either has to have the sound of a male pig or the sight of a male pig nearby for the mating stance to go in. So the idea that a pheromone, even in the animal world, can induce a reflexive response may not be that right. The entire thing is a fascinating story, but it might not just be subtle for humans. It might be subtle, more subtle for animals than we've been thinking all along too, okay? So the influences are subtle, and subliminal odor can have subtle effects, but they are not determinate, okay? They are like, thinking of Marvin Gaye music and how that does subtle things to our mood when it comes to things like reproduction and that sort of stuff. Okay, so let's take a tiny break here. Listen to a little Marvin Gaye. And let me try to answer your questions first. Oh, sorry. There goes Marvin Gaye. No problem. Let's look at chat here. Oops. Okay. So a couple of quick questions. The audio lagged a longer period this time during the bullet point. Ovulation heightens women's sensitivity to this. So it's hard to understand. Sorry about this. The idea is that ovulation seems to increase the woman's sensitivity to things like the man's symmetry. So it does seem to have some sort of biological kind of connection. What else? Does this depend on whether the men are, let's say, family versus a partner? I don't know what that has to do with, unfortunately. Sorry about that. So maybe you can clarify that, Araceli. What you wrote is, does this depend on whether the men are, let's say, family versus a partner? I don't know what that is referring to in what I was discussing. So if you want to clarify that, you can. Are there other questions at this point? Oh, how they affect, oh, the smell of men and how they affect women. Does this depend on whether the men are, let's say, family versus partner? But does the smell of men affect how women? So you're talking about the whole thing, I guess. Maybe you're talking about in all these cases. Does it matter whether you know the person or not? Yeah, it will. Okay, yeah, like skin moisture, cortisol. That's a very, very good question. I completely understand now. So these subtle effects on cortisol, heart rate, and all that sort of thing. Does it make a difference if the women knows who the man is? That's a great question. I do know that it is an unconscious sort of detection. In other words, the olfactory system is working without ever knowing a smell is there. So my guess would be it might not make a difference whether it's a man that they are aware of and not aware of, but it's a really good question. I don't know the answer to it. Thank you for asking that. Other questions at this point? We can go through a polling question. I think you like those for some obvious reasons. Yeah, okay, let's do that. Let's go through another question. Yeah, the startle reflex. We'll go through 2 questions. How do you like that? Oh, gosh. The startle eye blink reflex. So we've talked about that many times. A can be induced by smell alone. B can be induced by sound alone. C can be amplified by a smell. Or D, both B and C. So the startle reflex, the eye blink reflex, can be induced by smell alone, that's A, can be induced by sound alone, that's B, can be amplified by a smell, that's C, and D is both B and C. And let's see how you do on this one. Okay. Good, you're doing great. Give you a few more seconds here. Okay, that's good. I'm going to stop it here and make sure I have time to explain this. Most people got this right. The answer is B and C, but not everybody. So let's talk about that. The startle eye blink reflex can be induced by smell alone. Actually, it cannot. And this is important. I might have said this quickly, but certainly the book says it. But the startle eye blink reflex is something that comes from sound generally. It can also come if you puff some air at an eye. But smell on itself cannot induce the reflex itself. What it can do is amplify the reflex. So answer B can be induced by sound. That is absolutely true. Answer C can be amplified by smell. That is absolutely true. Okay, so the correct answer is both B and C. Good. Let's do one more. And this one has to do with cookies. So the question is, one way to get someone to clean up a few more cookie crumbs, okay, remember this experiment, is A, present them with a strong, noticeable odor of cookies. Will that get them to clean up the crumbs? B, present them with a weak, undetectable odor of cookies. Okay. C, present them with a strong, noticeable smell of cleaning fluid. Or D, present them with a weak, undetectable odor of cleaning fluid. That's D. So let's see how people would do with this one. Okay. So it seemed a little bit more challenging for people. So we should stop here and make sure, I'm going to stop it here a little early to make sure we can explain it. It's important. The correct answer is D. Cookie smells have nothing to do with this at all. The cleaning up of the cookie crumbs has to do with smell of a cleaning fluid. And importantly, the cleaning fluid has to be presented at a subliminal level, at levels below detection. If it's a very strong smelling cleaning fluid, it's not going to have that sort of influence on cleaning. It has to be a subliminal influence for this to work. So the correct answer is D. You present them with a weak, undetectable odor of the cleaning fluid. Okay? Cool. There are some, I'm going to get rid of this now, and there are some questions. So, good. Chelsea asks, would presenting them with a strong detectable smell of cleaning fluid have an adverse effect? Well, it's a very good question. I guess if it's a strong enough smell, they might not want to eat a cookie, right? But if anything, will it make them messier? I don't think so, but I know it won't help them clean up. It has to be below, and this is answering Aida's question, it has to be below what we call our threshold, our subliminal, it has to be subliminal below our threshold of awareness. Okay, it has to be something that we aren't noticing consciously. Okay, great. Okay, so this is now officially the end of the class period, but as you know, much to my exhaustion, I am going to continue to teach. And it looks like I'm going to have to continue to teach for probably about a full hour. So let's see, what should we do here? let me just take a couple of seconds to kind of get reoriented here. All right. The problem here is I'm despite the beautiful weather out at the Santa Monica pier, I'm actually in my garage, and it is very warm in this garage. So it's been more difficult today than usual. I might have to take a couple of little breaks as we go through the remaining hour here. I know a lot of you have to sign off. That's no problem. This is still recording. Everything's going great. It's going to be available to you. Any other questions before we start talking about taste? Everyone doing okay? If you want to run to the restroom, you can do it now. I'm going to actually start talking about taste by presenting a little video clip. No problem. Looks like about 90 of you are still here. That's nice. Okay. All right, then let's do that. Taste is on the exam, Natalie, and yes, Alex, you're welcome. Taste is on the exam. Just what I'm doing now is I'm just, I know a lot of you, or some of you at least, prefer getting the information through lecture as well as the book, and it's important you read the book, but I'm just kind of trying to clarify things for you and certainly give you an idea of what to emphasize in your studying. You could do this also by looking at the slides that are available to you, but I know some of you prefer to have me talk about this stuff. So I'll just go ahead and do this. No material beyond the book or beyond the slides is being presented now. I'm just chatting, okay? All right, so let's now share our screen. Oh, just a second here. Oh, there's Marvin Gaye again. That's nice. We should just listen to Marvin Gaye all day and not do any more learning. Okay, let's do this. Okay, then go back here and share our screen. Oh, let's see. Okay. Share our screen to taste. All right, make myself big. And what I'm going to do to start off talking about taste is talk about an experience I've had that if you've read through the taste chapter, you're familiar with, and that's going to a restaurant in Hollywood, which I believe is no longer there, or has moved maybe. I think it moved to Santa Monica, where you go in and it's a completely dark restaurant. It is the darkest place I've ever been in my life. You go in and the idea is that because there's no distractions of other people next to you or the decor of the place, being in a dark restaurant potentially will allow you to taste the food better. That's how it's advertised, at least. And what I'm going to do is show you a little video of that, of these dark restaurants. I know it's not going to come out great. As I understand it, the sound is okay. But let me show you the video, and then we'll talk about my own experience in the restaurant. Oops. I'm assuming you can hear this okay, even if it's video's a little clunky.
I came here tonight because it sounded different. They said it's dining in the dark. It's probably a little unique and disturbing, but that's why we're here. Welcome to Dining in the Dark. Y'all make this special.
Dining in the dark is a dining experience in a literally like dark dining room where all the food is served by blind servers, and that just makes you have like a totally deeper, greater understanding of the other senses that we all have, but often neglect.
Found my butter knife. Is there any butter? Yeah, it's in the middle of the table, which is here.
The whole idea of dining in the dark comes from Germany. Ever since that first restaurant got so popular, so trendy, so a good thing to do, they started sprouting all over Europe. I took an American friend, and she just said, like, why is the good stuff always happening in Europe? Why do we Americans always have to travel to Europe to actually go do fun stuff? And then we just like started talking about it, and that's how we came up with the idea to do this in the United States.
Opaque dining with blind leading the blind. What the awesomeness of it is, although they can't see, I can guide them into a great evening of dining. I'll be there either way. All right. Someone is entrusting me, a person who cannot see, to guide them and lead them into a dining experience.
The server takes them to the table. The servers exactly know where they're going. So the diners, as soon as the door shuts, they're lost. The server really acts as a guide for the entire night. The blind server is like the only person that can actually do the job, because they have like had that disability, which now becomes their ability.
No, I know there's no way. I may as well just close them.
I'm not sure. So no hope. Yeah.
Okay. I think I'm going to stop it there because I don't want to take up too much time watching the whole movie. It's a pretty long movie, but that hopefully gave you some idea of what the experience is like. And the question I'm going to kind of pose as we go through the discussion today is the following. Dark restaurants, does the food in fact taste better? So that is how they advertise. And I believe if you go to the website of this restaurant, Opaque it's called, and I believe it's still open in Santa Monica. They moved from this kind of very expensive Hollywood place to a smaller restaurant in Santa Monica. That they will advertise as a way for you to really have a chance to taste your food. And the question is this true? Is this the best way to taste your food? Is it a good thing to taste your food in the dark? So that's the question. Let me give you a little background on the restaurant, what my experience was like. You're given a few choices on how you want to order. So before you go into the restaurant, you can sit out in the lobby and chat with people before you go in. You're given a menu, and you're given the choice of I guess you're given three choices. You're given the choice of looking at the menu and choosing exactly what you want, choosing whether you want a kind of general category of food, so less detail you're choosing, but whether you're getting a vegetarian dish or a fish or chicken or beef or whatever. Or you can just say, whatever the chef wants to give me, I don't want to know what I'm eating until I'm eating it. Okay, so I chose, I believe if I remember it correctly, a vegetarian dish, just because it seemed safer. And I had no idea what it was going to be, but I knew it was going to be mostly vegetables. So again, it is the darkest place. When you go in there, I have never been in such a dark place in my life. I've been, in very dark rooms and cabins in the woods and stuff like that. And I have never been in a place so dark. There is nothing to see. Nothing. It is a very odd feeling when you go into this place. I was with my wife and another couple we're close friends with. And, they serve as a normal restaurant. So they brought out our drinks, they brought out bread, that sort of thing. And one of the first things I noticed is that the beer, which I can't remember what type of beer, maybe a Sierra Nevada beer or something like that, they had brought out to me, it didn't taste right. Maybe they gave me a old Sierra Nevada that had been, expired. It didn't have the flavor I remembered. And then they brought out the bread, and the bread had this really wonderful texture. It was very, very moist, but it didn't have a lot of flavor. And that seemed to be the story throughout the evening for all of us, that we thought, this is an expensive restaurant. At that time, it was a really expensive Hollywood restaurant. It was a tax write-off because I was writing about it in the book. But as we're going through the meal, we're thinking, gosh, this food's not very good. The food's not very good. And how many times have you gone to a restaurant that's expensive and none of the dishes are very flavorful? Okay, it was really odd. It was a really odd experience. Even things we'd had before, like our drinks that we've had in other places, like Sierra Nevada, didn't taste right. Okay, that was the experience for all of us. So what's going on here? Well, what does the research suggest? And it was interesting when I did this. I should tell you this part about it too. When I went to the restaurant, it was early in the process of writing the book, and I had not looked at the literature on taste perception yet. I didn't know very much about it because I don't typically teach that for very long in my perception classes. So I didn't know very much about it. So after we went out to the restaurant, I ran back and started to look at that research, and it's something that I learned very interesting about what the experience I had in the restaurant was probably about. There's a lot of evidence that what you see influences what you taste. And so a lot of this research comes from, companies that make fruit drinks or that make desserts or something like that, and they add color or the intensity of a color to different sorts of foods to maybe make them seem like they're cherry if they don't taste cherry enough. And what do you find in that research is things like sodas, things like fruit drinks, Gatorade, that sort of stuff. What people respond saying about the flavor of the drink and how flavorful it is depends a lot on the color. So yes, certainly, if you want to get an orange drink to taste more orange, you can put a very, very, kind of bright orange food coloring in it, okay? But it's not just that. Okay, it's also like if you have an orange drink that's maybe moderately strong and put a red food coloring in it and ask people what they're tasting, they're likely to say it's cherry, not orange. And vice versa. Like if you have a moderately strong cherry flavored drink and put an orange food coloring in it and ask people what they're drinking, they'll say, I think this is orange. Something else that's really interesting that's happened since since I wrote the book and went to this restaurant is I now drink these soda stream things. This thing where you have regular tap water and then you have a machine that puts bubbles in it and then you add flavor to it. The flavors that you add are typically colorless. Okay, they're very kind of light flavors that aren't composed of sugars or anything like that. It's kind of like it's kind of like an aromatic flavor, like through the nose sort of flavor, like tangerine, pineapple, coconut, that sort of thing. And very often when I have these sodas, my wife will ask me, "Oh, what flavor soda is this?" She likes some more than others, and I'll take a sip of it so I can tell her. And because it's clear, I'll say, "Oh, I recognize the flavor, but I can't remember which one it is," in the sense that it's a familiar flavor, but I can't tell you if that's tangerine or cherry or whatever. And so a lot of our sense of a flavor of a drink comes through what we see. And that's not just true of things like soft drinks, Gatorades and things like that. It's also true of cookies and custards and cakes. The color, the apparent kind of texture, the viscosity of the food will influence how it tastes strongly. And that's especially true when it comes to custards and cookies and cakes and ice creams and things like that, when it comes to the texture, okay? When it comes to the texture. So there's some very kind of clever experiments you can read about where what they do is they take a bowl of custard, say, something like this, and they have you taste different custards through a straw. So the straw goes into the custard and you're sipping the custard through the straw, and you're asked to say, how flavorful is this custard? This is a really cool experiment because it's like a magic trick experiment in that the custard bowl actually has a secret compartment in it. So there's custard on the top that you see, and then custard on the bottom that the straw is connected to. So the straw is actually sipping a custard down here that's different from the custard you're seeing. And so you could have a very kind of thick custard on top and a more kind of liquidy custard on bottom. And you'll sip it, and based on whether you're seeing on top a thick custard or a liquidy custard, your sense of the custard's flavor will be dependent on how thick it looks to you. So I've got two bowls of custard here. Here, let's just do it this way. They're both these sneaky magic bowls, magician bowls. And on the bottom compartment of both of these bowls is the same exact custard. Okay, it's kind of a moderately liquidy custard. But on top, the thing I'm not truly putting in my mouth, but only looking at, right? It's a magic trick. it will influence it. So I sip the custard here, the bottom bowl custard, and I say, okay, I look at the custard and it's thick and I say, well, this one doesn't have as much flavor as this one. I'm truly just eating the same exact custard, but the one on top is thinner looking. Yes, this one has more flavor. So the apparent, the visible thickness of the custard will directly influence how things taste to me. In both cases, I'm tasting the same custard, same exact custard through these magic bowls, but because I think I'm tasting a custard that looks different, it will affect my sense of flavor, which is fascinating, right? And it also allows you to do things like discriminate custards and that sort of thing. Don't worry too much about this discrimination thing. Just if you remember about this kind of magic bowl experiment, it also can work in the context of whether you can discriminate that two custards taste the same or different, right? But in terms of your preference and how flavorful a custard seems, it will depend on how the custard looks. And importantly, you'd say, well, maybe this is something that we're almost conscious of doing, that we've seen these cooking shows and we know that this is the sort of thing that we know that what we see influences what we taste, and maybe we take that into account at a kind of semi, aware level. But I don't think this is the case. It's not like an afterthought. These are truly perceptual effects in that they truly trick the perceiver. That's what I guess I mean by this, right? That it's not like, you consciously, of course what I see influences what I taste. Even knowing that, you can still be very clearly tricked. And this is established through very kind of careful tests to make sure it is truly perceptual, as well as some neurophysiological testing. You put people in a MRI scanner and you look to see how their brains are responding to different sorts of flavors, and you find that their brain responds to flavor based on the sort of thing they're seeing. And in fact, what you see in the areas of your brain that detect flavor, the same cells that are going to respond to what's on your tongue are also going to respond to what you are seeing. In other words, these cells in some ways are going to take in information from what's being seen in a food and what's actually on the tongue in a food. And these cells don't really care, where the information is coming from. They are automatically integrating all this information. Also, you've learned in your discussion sections very well that smelling is going to have a huge influence over how food affects how a food affects our sense of flavor. So smelling the food is maybe 80, maybe even more percentage of what determines our flavor. And that's very clear here too, in that smelling of food not only affects the parts of our brain that are responsive to flavor, but also responsive to what we're seeing in food. So there's these massive connections that are integrating all this information about food, not just through what's on our tongue, not just through what's coming through our nose, but also what's coming through our eyes. And this research shows that if you can't see what you're eating, it dilutes your sense of flavor. So, does food taste better in a dark restaurant? No. Now, I don't want to be sued by this restaurant, but it is all the research suggests that if food doesn't have an appearance, if food doesn't have color, if it doesn't have visible texture to it, right, it doesn't taste as strong. It doesn't taste as flavorful. Which is why myself, my friends at my wife, my friends at the restaurant, all had the same experience. The food, it's a fun experience to go into a dark restaurant. It's kind of cool, right? But the food doesn't have as much flavor as it usually does because we can't see it, okay? Now, I know what you're thinking. Does this mean blind people have less of a sense of flavor than sighted people? Do they taste their foods as being more diluted, okay? And the answer is probably not for people who've been blind for some period of time. Usually what happens then is the other senses kind of start to come in and compensate for the lack of seeing. So maybe you rely more on your sense of smell, maybe more on your sense of touch, how the touch of your tongue to the food might affect flavor. So blind individuals love eating. They don't taste their food probably as more diluted, unless they are newly blind. And that is one of the first things that the newly blind will report. If, you know, someone loses their sight in an accident or, you know, from some kind of spontaneous event, they will say that one of the first things they notice is that food tastes more bland. Being blindfolded for an extended period of time, okay, also can be affected, it can also affect your sense of flavor. And we're going to be talking about some experiments when we discuss touch after the exam that involve subjects, you know, undergraduates coming in and kind of checking into a hospital room and then being blindfolded with a serious blindfold for 5 days to kind of check how their brain changes with touch. What often people report in those circumstances is that, yeah, it's a pain not being able to see anything, but I really thought that, you know, I'd be able to enjoy the meals that I was getting in you know, in my hospital room. It's hospital food, but still I'd enjoy the crackers, I'd enjoy whatever snacks I was bringing in with me. And they'll say that one of the first things they notice is that food has much weaker flavor when you can't see it. And so should you spend a lot of money to go to this dark restaurant? Well, again, it's a cool experience if you're interested in the senses. If it's kind of fun because, you know, you're trying to feed yourself and things poke your face, and it's, you know, it's kind of a fun first date maybe, you know, kind of breaks the ice, and it's an interesting experience if you're interested in perception. But should you expect the food to be great? Not your experience of it, certainly. Okay, let me take a quick stop here, see if there's any quick questions. Anyone want to ask anything? Sorry. Oh, when did I go to the restaurant? Very good question. When I was writing the book, so 2009, 2010. Okay. I don't think it's, I know it's not in Hollywood anymore. I don't know if it is still open in Santa Monica. But yeah, you can look it up, see if that's the case. Other questions about the restaurant? You don't have to. I just want to make sure that I had a chance to answer them. It'd be fun. No? Okay. Okay, no, it is in Santa Monica. It's still there? Okay, good. So maybe, so next time you're there at the carnival, at the Santa Monica Pier, stop by, make a reservation, stop by the restaurant. I guess it's still open. Thank you, Araceli. Cool. Okay, let's go back then and share. Screen, cool. Okay, let's go on. So it's very clear that seeing affects food. Okay, very, very clear. That seems like it's you know, very, very rigorous research doing that. But some other research came out recently. I think you're going to find very interesting. That has to do with how what you hear can influence your sense of flavor. Okay. And let me just talk about this. It's single, well, I guess it's been replicated now a few times, but the experiment is very simple to describe. So how crisp we might judge, say, a carrot, oops, or how crisp we might judge some celery will depend on how we hear it. Okay, and as it turns out, you know, if you're chewing on a carrot, the crispness that you hear will influence how crisp you believe the carrot is. But if your sibling next to you or somebody in your family is chewing a carrot while you're not, your judgment of that crispness will be the same. So whether or not you're doing the chewing or somebody else is doing the chewing, what you hear is going to tell you something about the crispness. And based on that, a group of researchers in England decided to, or maybe it was Italy, decided to test if they could manipulate the sound of food to change how flavorful, how appealing that food was. And they did it in a really interesting way. But before we go into their experiment, I need to tell you a little bit about how we hear food as we're chewing it. And actually, it's something you might know a little bit about. That let's think about our own voices. So maybe you've noticed, I've certainly noticed and continue to notice as I have to listen to the videotapes to make sure they've recorded that, boy, my voice sounds so much better to me as I'm talking than it does on a recording. Have you ever noticed that before, right? That when you hear your voice recorded, it sounds thinner, maybe less authoritative, right? I don't like listening to my voice when I'm on a recording, my speaking voice, let alone my singing voice, right? And there's an interesting reason for that. It's because when you're talking, you're actually hearing your voice in two ways. You're hearing your voice come out your mouth and into your ears through the air, but you're also hearing your voice actually go from your vocal cords through your bones, which vibrate sound, into your inner ears, okay? And what that does is it actually provides another means of sound for your voice, okay? It's called air versus bone conduction. And that's what this little figure is showing down here, that your vocal cords actually vibrate through your skull and go into your ears directly without having to go out, okay? And that bone conduction is what makes your voice seem more resonant to you when you're talking. It makes it seem a little bit more authoritative. It makes it seem like, a little bit maybe lower and fuller. The way the rest of us hear your voice, I'm afraid, is the way the recording hears your voice. But that's why our own voice sounds different to us as we're speaking. This also has a bearing on how we hear food as we chew. So as we chew, we are opening and closing our mouths, okay? And that is influencing how much air sound we get from our chewing versus how much bone sound we get from our chewing. So the relative importance of the sound we hear as we're crunching on that carrot through our, depends on whether we're getting the sound through our ears, more of it through our ears or more of it through our skull. And as we open and close our mouths, that's going to change. That's important. Okay, knowing that, they actually did a very interesting experiment to see if they could influence how flavorful, how appealing a potato chip was based on the manipulated sound. So this is how it was done. They put somebody in a sound booth. Do I have this? Yeah, they put somebody in a sound booth. That's what it looks like right there. And the sound booth was closed, and so they couldn't really hear anything else. And they put headphones on the person, and they used a little white noise to kind of get rid of a lot of, there's ways of kind of dampening down the bone conduction. They did that to kind of make sure that most of what was coming through as the sound of the potato chip was what was recorded on a microphone or picked up by a microphone, sent through a computer, and then went into their headphones. So that's the idea. Here I am, a subject. I'm chewing on potato chips, and my job is to say how much I like these potato chips, whether they are fresh, whether they are appealing, whether I like them, whether they're tasty, that sort of thing. I'm blindfolded. I'm in a sound booth. I am chewing as I chew. There's a microphone picking up that sound. That sound then goes immediately through a computer on which the experimenters can manipulate the sound. And then that manipulated sound immediately comes back to my ears. So basically, I'm hearing what the mic is picking up as I'm chewing. And there's no delay in this, really. No delay that's noticeable. And the sound is coming back to my headphones. But what this allows the experimenters to actually do is to change the nature of the sound as the person is chewing. And what they found was, if in fact they take the sound and make it a duller sound, so you could do this on your own car stereo, you kind of turn down the treble on your car stereo and you maybe turn up the bass or something like that, it sounds more like a dampened sound. If they do that, the sound will change in the headphones, and people will say that the food or the potato chip sounds, not sounds, they're judging the flavor. It has a duller flavor. It maybe is less fresh. It is less appealing. Versus if they take the sound of the crunching and they put it through the computer and back in the headphones and turn up the treble and maybe turn down the bass a tiny bit, people will say it seems like a fresher potato chip, one that's more appealing, one that is more flavorful. Oh, by the way, Pringles. Yeah, I should mention why I put Pringles up there, just to remind myself to tell you that they were always eating the same potato chip. They never changed the potato chip, even though they were told that they were. And how do you make sure they always eat the same potato chip? Pringles are always Pringles, right? There's no difference. They just cut them in different, at different shapes to make sure that, it wasn't obviously a Pringle, but it was always the exact same potato chip they were eating. And how much they liked it, though, and the fact that they thought it was a different potato chip was determined by how the sound was manipulated as it came back to their ears. And so just very quickly to review what I said, if it's a louder, brighter sound, they thought it was a crisper potato chip and they liked it more. If it was a quiet, dull sound, they thought it was a stale potato chip. They thought it had less flavor and they found it less appealing. Okay, so not only can sight and smell influence how much we like a food, how flavorful a food is, whether we think it's fresh or stale, the sound can also influence our sense of flavor. There's this very clear story that's we're building up here today, where our sense of flavor is so multisensory. It's so influenced by so many different senses that what we get on our tongue is actually relatively little of what we actually experience as flavor. Okay, let's continue talking about this, and now talk about how touch influences our sense of flavor. Okay, and what I wanted to talk about is something called tactile capture. And this is your book does a nice job, if I can say so myself. Your book does a nice job of describing this, but I want to go into this a tiny bit to make sure you understand it. This is one of the reasons I thought it'd be a good thing for me to lecture a little bit about this, because it's a tiny bit confusing. Okay, so I wish I had a Tic Tac here or something so I could demonstrate this for myself, but you've noticed this before, whether you have a breath mint or a hard candy or something like that. When you put it in your mouth, it's very clear that the flavor of the candy follows the candy itself. You're kind of swishing it around your mouth. It's going to the front of the tongue, the back of the tongue, the sides of the tongue, sometimes all the way to the side of the mouth, maybe on the other side of your molars, not even near your tongue, that sort of thing. And it certainly seems very clearly like the experience of flavor is emanating from the candy. However, that can't be the case, because when the candy hits your tongue, it can only signal, for example, sweet when it is in a particular area of your tongue. So maybe you've learned this in other classes. Different regions of the tongue are sensitive to different flavors. And we're talking about core flavors here. We're not talking, that smell is such an important part of flavor, but we're talking about the core flavors of sweet, salty, bitter, sour. There might be another one or two that scientists are now considering. But in general, sweetness comes from the front of the tongue, bitterness comes from the back, sour from the sides, and salt maybe a little bit behind where sweet comes from, okay? And so what's happening then, as the candy floats around your tongue, the sweetness from a candy, so it's just now a candy that's just purely sweet, there's no sourness, it's not like Sour Patch Kids or anything like that, it's a purely sweet candy. Sweetness seems to follow the candy. And the fact that the sweetness can't be detected when the candy is on the back of the tongue is something interesting. It's sometimes called the sweet tongue illusion, okay? Because what's going on is where the candy is touching your tongue, okay, even if that part of the tongue can't pick up sweetness, it allows that flavor to follow the candy around. So where your tongue is being touched by the candy, okay, might not have the chemistry to pick up the sweet flavor, but the fact that it's being touched kind of fools your brain into thinking that the flavor is being there emanating from the candy. So the sweetness that you're experiencing on the candy, which is on the back of your tongue, isn't actually being detected by that part of the tongue itself, but the fact that it's being touched there, the fact that you're having a tactile sensation beyond the chemistry of what's going on, fools the brain into basically thinking that sweetness is now on the back of the tongue. In other words, there's an illusion based on where you are touched that brings the flavor with the food. Let me say that again. There's an illusion of where in your mouth, not just the tongue, but where in your mouth a candy or a piece of food touches brings the flavor along with the food. So touch clearly has an influence on how we taste food, because it can induce this illusion where flavor seems to follow food, even though chemically it doesn't. Okay, that's one thing. I am going to skip this next term, this blind spot analogy. It's not on your exam. It's going to take a little while to explain. If you're interested in it, you can read it in the book, but it is something I'm going to skip now because it's not worth the time. But I wanted to talk about how other things that had to do with touch influences taste. Okay, so the texture of something. So, we talked about the visible texture of a custard can actually influence how strong something tastes. That's not just true with the visible texture. It's also true with the texture that we feel in our mouths. So say your eyes are closed, you're putting a spoonful of custard in your mouth. If your mouth experiences that custard as having a thick texture, a viscous texture, thick, viscous being the same, it will actually experience it as having a weaker taste than if, in fact, the texture of that custard is a little thinner. And in both cases, the amount of sugar is the same, the amount of flavoring is the same, but the texture that we experience in our mouth will influence how strong its sugar taste, how strong its custard, kind of its milky, flavor tastes. So how we feel something, how we feel a food on our tongue, this is now just talking about touch, the touch of the food on our tongue, the touch of our food on our lips, on our cheeks, all that sort of stuff will influence how strong the thing tastes, how its flavor tastes. Other simple things, the temperature. And this is actually one of the most relevant things to chefs and restaurants. The temperature a food is served at will influence how it tastes to us. And maybe they were very aware of this, that you don't like tasting food in a restaurant that's lukewarm. You don't like tasting things that are too hot, and it hurts, of course, if it's too hot. But even if it's not really hot enough to be painful, you might notice that if it's warmer than it typically should be, that the flavor isn't as strong, right? There's this, kind of a very kind of important part. I think it actually is 98.6 or something like that, where the food should be served, and that's where we are most sensitive to food flavors. If the temperature is off and we experience that temperature through touch, okay, the flavor changes. And even a change, so we're most sensitive to food at tongue temperature. That's the first thing. And I think tongue temperature is 98.6, like the temperature that we get when we put our thermometers under our tongue. I think it's about that. I can't remember. You can look in the book. You're certainly not going to be tested on that exact number. But we want the food to be at tongue temperature for the most part. That's when things are most flavorful. And even a change in degree of plus or minus 2 can change the flavor, which is why restaurants put so much effort into making sure that the food is served, fine restaurants, making sure the food is served at the right temperature. Most food, when it's sent back at a restaurant, is because of the temperature not being close enough to tongue temperature, or at least the entree is not being close enough to tongue temperature. Okay? And there's a couple of other things that I think you'd find interesting about flavor and temperature. And that has to do with what's called phantom flavors. And this is something that chefs are also aware of too. If things are served too cold or too warm, it can induce kind of an illusory sort of flavor, kind of like this sweet tongue illusion I talked about before. In that if you take water and say, this is just pure water filtered to make sure there's no kind of weird chemicals in it, or minerals or anything like that, that if you make it a little bit warmer, people, and then you ask people, okay, we might have added something to this water. Would you think it's a sugar solution or a salt solution? If the water is warmer, they will say that it is likely had some sugar added to it. If, on the other hand, that exact same water, exact same sample that's now made colder with nothing added, people will say that it tastes more salty. And this is kind of something that the tongue just reacts to, and the cheeks just react to. By touching the food, establishing the temperature, it has an effect, and enough of an effect to induce these kind of illusions of something having a sweeter or a saltier taste. And it's not surprising then when you look at the brain, you do these MRI studies, you look at the brain and you find that in fact, the taste brain is filled with neurons that are not just sensitive to the chemical changes on our tongue, but also to how the tongue is touched and how the cheeks are touched and how the lips are touched as we are ingesting food. So you've learned now it's not just the the food that chemical activity that occurs on our tongue for salt and sweet and bitter and all that stuff, sour, and not just the smell that you've learned so much about in your discussion section, and not just the sight, which you learned about through the dark restaurant and all those studies, and not just the hearing that you learned about in the previous slide with regard to that potato chip experiment, but how the food touches your mouth, okay? Its viscosity, the location in your mouth of the food, all of those things can directly influence flavor. So the big picture here is this: you taste what you integrate. Your sense of flavor is possibly your most multi-sensory sense of all. That very, we think of, we experience flavor on our tongues and our mouths, but very little of it has to do with those chemical changes on your tongue. It has to do with all your senses, and they can all have a direct influence on your experience of taste, without question. Okay? Incidentally, they can also have kind of these weird indirect influences too, just kind of as an aside here. Things like the smell of a food can actually affect how viscous a custard. So if you smell a custard and then you're asked to judge the viscosity just by smelling it, and then you look at it and then judge it by looking at it, your sense of the visible viscosity, how thick it looks, will be influenced by smelling it. It's never been in your mouth at this point, right? You smell a custard, okay, I smell it. Now I look at it, I say, okay, that's a custard with a rating of 5 viscosity, and then you smell another one, that's a custard with a rating of 10 viscosity, okay? The smell's gonna have an effect on that. And then when you put those custards in your mouth, the influenced viscosity will then affect your flavor. So smell can affect a visible viscosity, which can affect how it affects your sense of flavor. And texture can then affect the perceived temperature of something. Something has a thick texture, it can change the felt temperature of the food, which in turn can affect your flavor. So all these kind of sensory inputs coming from all our senses can have a direct influence on our sense of flavor, and also they can affect each other to have indirect influences on our flavor. I say this in the book. It's kind of like, your sense of flavor is kind of like a chemist or something, and just kind of testing all these different combinations of what's coming through the senses. Viscosity as it comes through looking, viscosity as it's affected by smell, viscosity as it's then put in the mouth, and how viscosity changes flavor. It's really cool. And when you kind of know about this, it's not surprising that there's these cooking shows on. If you think about it, and my generation thinks about this a lot, I think, why are cooking shows so popular? Why are there so many of these shows on? People are sitting there, kind of, the whole point is to try to make the best possible food that then the audience never gets to taste. Yes, they get to look at it, and it gets to be described by these specialists, but I'm never able to taste the food, but still I'll watch these cooking shows. There's Cooking Channel, right? Why does that work? Well, because we do experience food with more than just our tongues. And so we can kind of do it almost vicariously as it's described, of course, but also as we're looking at it, as you see it cut into with a fork, cut into a dessert. My wife loves that British baking cook-off show. They kind of do close-ups of the fork going into the cake almost in slow motion. And so you're getting information for the viscosity there. So yes, you are never tasting these things yourself as somebody sitting at home watching it on TV, but you're getting all this other multi-sensory information about flavor, and it's not hard for us to imagine what it might taste like, which is so cool. So the fact that we are integrating all of our senses for the purposes of eating food, I think is something that kind of provides the basis for the popularity and the utility of these cooking shows. Okay, we're going to continue to talk more about taste, but we're going to change the subject. So let's stop for a second and do our chat. See if we have any. Oopsie. Okay. Okay. Lydia asks, if restaurants with dark lighting is said to have food tasting bad, then why do you think it is perceived as the best movies, TV? A little trouble understanding the question yearly. Restaurants with dark lighting is said to have food tasting bad. So it's not, I would say this is important. Okay, so, some of the best restaurants in Los Angeles have pretty dark lighting, and that sets a mood for not just the food, but it sets a mood for the romance and the social interactions and all that sort of stuff. If you can see your food, even if it's dark, if you can see your food, you're going to be able to incorporate the visual information to affect your flavor. I don't think we need to have bright lights on the food to have it affect flavor, although it might make a small change. But I think just being able to see it and, probably being able to distinguish the textures and the colors at least a little bit will be enough so that what you see will integrate with what you're tasting, and that will be sufficient. Okay, Chelsea asks, how come when we're kids we hate the taste of vegetables, but as we grow over? Okay, so we, learning to acquire new flavors, new tastes is something that is absolutely studied. I don't know that much about it, unfortunately. I think we all have the experience of learning to acquire taste for things. I do know that the tongue does physiologically change through childhood and adulthood and all that sort of stuff. But it might have something to do with that. I think therefore the brain probably changes along with that, but I don't know that research that well. Samantha asks, I am confused with the concept that as we taste sweet, sour, etc. in different, okay, yeah, I understand. This is a little tricky, and it's one of the reasons I wanted to make sure I went through this. Okay, in discussion, we were told that it is not true and that there are areas of the tongue dedicated to tasting certain flavors. Yes. Wait. You were told that it's not true that different areas of the tongue taste different flavors? Wait. I am confused with the concept that we taste sweet, sour, etc. on different areas of our tongue, because in discussion we were told that it is not true, and there are not areas. Okay, hold on just a second. There are not areas of our tongue dedicated to. I did not know that. I did not know that. Okay. Well, maybe this is very new research that somebody said. One of your discussion sections mentioned. Regardless, the fact that there are greater densities of certain taste buds in different areas, I imagine that still holds true, I believe. The fact that the flavor can follow the food, the hard candy around, even when it's not on your tongue, is what this is about. Where you are being touched in your mouth by some food will determine where the flavor seems and where it's coming from, even if there's no taste buds there like there aren't on the side of the tongue. Okay, so I think it still holds, but thank you for putting that out there. I will check about that. Have you seen Gordon Ramsay cook? It's satisfying. Yeah, I agree. I mean, I don't watch a lot of the cooking shows, but my wife does, and one of my boys do, and they all love it, and they'll be very into the challenge. They'll be very into it. My wife, after she sees these pastries being made, she wants to do them herself. They say, God, that looks delicious, and it's an interesting phenomenon. Absolutely. There are not separate areas. Sorry. Okay, no, I got it, Samantha. Thank you. Thank you for alerting me to that. I will find out about that. I guess maybe that's let's see. Yeah, I was also taught that the 4 regions of the tongue previously associated with sight was proved wrong, but you said that it's more about the illusion. Yeah, okay. So it could be that the idea that there are no sweet taste buds in any other part of the tongue besides the front is interesting. What was I going to say? So that could be that maybe that has been proven wrong, that it's not as clear cut as that, but still the fact that the piece of food, again, think hard candy, can float around the mouth regardless of the density of different types of taste buds in different areas, or even if it's off your tongue, suggests that the flavor follows the food depending on depending on how your mouth is being touched. Okay. As long as your mouth is being touched by the food, the flavor is going to seem to follow the food, even if there's no taste buds in that area, or a few taste buds that can actually detect that flavor. Okay, that's the point. Good. People just eating food and recording this. There are millions of videos online. Chelsea says there are millions of videos online of people just eating food and recording the sounds of themselves eating. Wow, I did not know that. That's what I'll be doing this afternoon. That's really interesting. That's really, really interesting. I wonder if it's part of that, kind of whatever that's called, the thing people like where, very quiet sorts of sounds are produced over the microphone and people find that soothing. Maybe that's related to that. That's really interesting. ASMR, yeah, that's it. That's it, ASMR. Thank you, everybody. Let's continue talking, though, to make sure that we can get through everything. I'm going to shift gears a little bit here, and we're going to continue talking about flavor, but we're going to talk about it in the context. Oh my gosh, I realize I'm coming upon almost an hour already. Oh gosh. Okay, I'm going to go through this a little bit more quickly. This is directly out of the book, so I don't think we should have it. But we're going to move to talk about a different type of tasting, and this is a master sommelier. This is Steve Poe. And he is a sommelier, as you probably know or might know, is the person in a restaurant that recommends wine and recommends how to choose a wine based on the type of food one is eating. And a master sommelier is the group of individuals who train the individuals who are at these restaurants. So they are the ones that really need to know this sort of stuff. And when I wrote the book, there were about 167 or so, but I think there are now 214 in the world. So it's still a very small number, and they're trained in, I think that the test can be in France or whatever, but it is a select group of individuals, and it's a select group because it's a very hard program to get through. It's a very hard set of tests to pass. And there are 3 exams that are given, and it takes many, many years to pass them. They are taught about wine theory and have to do tests on that. They are taught about serving decorum, the best way to serve wine, and also they serve, I think they have to learn a little bit about cigars too or something like that. But the thing that stumps them most and prevents people from being certified as master sommeliers is the blind tasting. And what the blind tasting involves is them sitting at a table with 6 unidentified glasses of wine in front of them. And they will either be all reds or all whites. Typically, they're going to be reds for the master sommelier. And what they have to do is sip the wine and report what they think the wine is. Not just, it's a red wine, it's a rosé, it's a, Zinfandel or something like that. They have to also identify the region in the world the grapes are from, the type of grape variety, of course, the vintage, meaning when it was bottled, possibly, when the grapes were grown, when it was bottled. All these things have to be more or less identified correctly for each of the wines, okay? It's a really difficult thing to do. And as they're doing it, they have to describe their thought processes as to why they're selecting this wine as being from this vintage, from this winery in southern Italy or something like that. They have to be accurate, of course, but they have to give their reasoning for choosing the answer they're choosing and a description. And they're doing this in the course of 25 minutes as they sit across the table from some masters who have already been certified that are judging how they're doing. And I have a very quick quote here from what Steve Poe's experience is, and this is directly from the book. Steve Poe said, "I remember that I was working to identify the last of my 6 wines. Time was running out. I had looked at the wine's legs, and that's looking at the glass and seeing, as you swish the wine around, how it kind of drips down from the inside of the glass. Those are the legs, right? I inhaled its bouquet, and then I had taken a sip. I was trying to describe it as if it was an overripe Cabernet Syrah blend. So they also have to determine when 2 different wines are put together to be blends. And they thought that initially it was from Australia, but something just didn't seem quite right. I thought again about its characteristics. It was a little off dry, meaning more tart than sweet. It was big, which meant that it had a lot of flavor, and it was high on alcohol, which is something I could imagine you could taste. It had a spiciness, okay? I'm not a wine connoisseur. I don't know what that exactly would be like. And it tasted a little of dried raisins. Okay, I can imagine what that might be like. And then it just clicked. Oh my gosh, this is an Amarone, which is a red wine from Veneto, Italy. It was one of those situations where the studying and the focus just took over. And this is the interesting thing about this process for these individuals, I think. they are not just practicing to become master sommeliers. They are not just practicing wine tasting. They are learning about wine production and grape growing and grape harvesting and all the different sorts of techniques that go into producing a wine in order to have a full knowledge of how wine is made. And this helps their understanding. And so what can we say about wine experts? Well, wine experts have an explicit knowledge, explicit meaning they actually study. And so what they understand influences how they taste something. So we've talked about how all the different senses can influence how you taste something. And now we're going to be talking about how what you understand, what knowledge you have can influence how you taste something. Because these guys, these wine experts, actually, I think there's now as many women as men, so these people have no better taste thresholds or discriminative ability for wines. I apologize, the gardener's back. Hopefully you can still hear me okay. He'll be out of the garage in just a second. But in other words, it's not like they can notice that a wine has been added to a glass of water, like a single drop of wine has been added to a glass of water better than the rest of us. And they have no better ability to say, these two wines are the same or these two wines are different. That is something we can all do pretty well. Okay? Wine experts like sommeliers cannot do that any better than us. Okay? And that's also true of smell, by the way. There's this very famous experiment where they took a glass of white wine and added red food coloring to it and then asked the people to smell the wine and then describe what the wine was. And what they found was if you put red food coloring in white wine, people describe it as if it's a red wine. If you don't put the food coloring in, people will describe it as white wine. So there's no question, again, another example where vision influences flavor here, okay? That also can I talked to Stephen Poe about this. He said, I can imagine that happens because he's very aware that, wine tasting is a multi-sensory experience. So he could imagine that's the case. But, okay, so the wine color illusion, that's the wine color illusion I just described, with the drops of red in that, yeah. But what wine connoisseurs have is a very different brain response to wine, okay? They have more activity in areas of the brain where smell and taste converge to influence flavor. So we know that that's an important part of flavor. Smell is 80% of flavor. They show more activity in those regions where smell can influence taste, okay? They also show something I think you're going to find very interesting. They show a difference in what's called hemispheric activity. And maybe you've heard about this story before, that we have two hemispheres of our brain, right? Kind of split down the middle here. And here's some you can use these images right here. This is a brain image right here where you're looking down on the brain. And you can see there's kind of a little line down the middle. And it's a little controversial about how different the sides of our brain are for processing information. But one thing seems fairly consistent is that if you're a right-handed person, the left side of your brain does more analytical sorts of processing. What does that mean, analytical processing? Well, if you're doing mathematics, you're going to be using more left side of your brain than right side of your brain. It's probably used more for language, the left side of the brain, than the right side of the brain. And that's, again, for people who are right-handed. For wine connoisseurs, when they're sipping wine, they will use more of their left brain area than the rest of us. In other words, they show, through these brain imaging sorts of measures, more sort of analytical processes going on. And it's also thought that they show greater activation in memory centers and language areas, which makes sense because what wine connoisseurs are very, very good at is a conceptual understanding of the wine and being able to apply terms to it, like, what was that word that was in the previous description? off sweet or something like that, or off dry, right? That was it. And kind of like a dried raisiny flavor and that sort of stuff. They have all these terms, and these terms kind of allow them to fine tune their experience of taste, which is pretty cool. I realize we've extended an hour now. I'm going to keep recording. I apologize for this. We've got about another 10 minutes. Sorry about this. I get too excited about these things and I kind of talk too much about them, but I'll continue going on. Sorry. So this is the big picture. You taste what you understand. And for Stephen Poe, having this explicit knowledge, and explicit knowledge just means like the knowledge you learn from books. When you read my book to study for the test, you're gaining explicit knowledge. When you're listening to my lecture, you're gaining explicit knowledge, the knowledge that you're conscious of. Having that conscious knowledge helps you attend to your senses. And that's what's happening here with Stephen Poe. It allows him to kind of attend to how flavors go together based on how a wine is produced. For example, there is a process in wine, hey, I didn't know this, called malolactic fermentation, fermentation is what gives the wine its alcohol. Malolactic fermentation is a second very small fermentation process that the wine goes through, which more than adding more alcohol actually gives the wine kind of a certain type of constellation of flavors that other wines that don't have malolactic fermentation don't go through, right? So if a wine goes, and malolactic fermentation is specific to certain types of wines in France and stuff like that. It's just a production technique that they do to give it a characteristic flavor. It adds what I guess they would call a buttery texture. See, here are the things that I would have no idea how to use these terms when sipping wine. Buttery texture, sauerkraut, yogurt, that sort of thing. I wouldn't know how to apply that sort of stuff. But basically what this does is if he is aware of what malolactic fermentation is, what part of the world malolactic fermentation occurs in southern France, that if he tastes sauerkraut in a sip of a wine, he can then sip again and try to taste that buttery texture and that yogurt flavor. And if those things are confirmed, bam, he knows that this is probably the constellation of flavors that can tell me that malolactic fermentation was applied to this wine, which means it's from this region, and on and on and on. This is the basis of their superior recognition performance. This is how they are able to perform this task. And they're also, by the way, when it comes to judging the similarities between wines, these folks, I mean, all of us can detect whether two wines are different, but whether they're saying that this one's more similar than that one, or more similar to that one, more similar to that one, they are much more consistent, and this is the basis of it. And I've got this great quote from him that really, really explains this well, I think. There's no question that the more knowledge you have, the more your tasting is informed. If you know, for example, that they use tufa subsoil in the Anjou-Saumur, that's France, okay. Then when you're trying a Cabernet and getting that chalky, stony minerality from the wine, I have no idea what he's talking about. But you can see that he really understands what to taste for. You become confident that you're tasting a Cabernet Franc from the Loire Valley, probably Chinois. I don't even know how to pronounce these words, let alone know how they apply to wine. And all knowing this can draw your attention to the other tastes associated with that region. So imagine he's at his tasting test and he tastes this kind of chalky flavor and he says, okay, that chalky flavor can mean a lot of things, but one of the things it can mean is that the grapes grew in a tufa subsoil. Okay, and if that's the case, not only should I taste chalky, I should taste that stony minerality. And if I taste that, then I can say, aha, tufa subsoil, probably Loire Valley, probably Chinois, whatever it is. And that can help him narrow the wine. And then based on that, he might be able to say, okay, I remember that in the different years, they had different sorts of seasonal influences over the grapes. And I can probably guess that this is that sweet, so it's from 1976, something like that. Somehow he's able to do this and get it right. But the point here is, the most important point here is that in these cases, you taste what you understand. This is the last slide. I'm almost done. Sorry about this. Thank you, 48 of you that are watching now. I'm hoping the rest of you will at least watch part of this later on. We are still recording, so it's no problem. This is the idea. Explicit knowledge. This goes beyond taste and talks about how explicit knowledge can enhance our perception. And we've known this in other domains for a long time. So for example, if you watch an expert chess player, you will find out that they can easily memorize the configuration of pieces on a board. So these are chess experts that are playing chess against, you know, a whole bunch of people at a time. And if you ever get a chance to see some of these videotapes, they're really amazing. So a chess expert would be in the middle of a horseshoe of tables and playing, say, 15 people, 5 here on each of the tables, and saying, okay, I'm going to move my pawn to queens 3 over here, and then over here I'm going to move my... And what they do without even having to look at the boards is they can just say where their next move is without thinking about it almost. It seems like almost second nature to them. And they are actually memorizing the pieces and the configuration on the boards, and they're amazing at this. It comes from years and years and years of practice, but they are great at memorizing the configurations. However, they can only do this, they can only memorize the pieces on a chessboard if the pieces have gotten there by virtue of the actual rules of chess. In other words, you could not, you know, say, take your chess pieces and put them randomly on the board and where they don't make sense based on the rules of chess, and your chess master will not be able to memorize that board. They can only make these memorization skills available to themselves if the chess pieces have gotten there based on the real rules of chess. Okay? Pieces can be put on the board that aren't constrained by the real rules of chess. They're hopeless. They're as bad as the rest of us would be at trying to memorize chess pieces. This is also true of musicians and coaches and circuit designers. So, you know, football coaches can remember the nuances of player positions and stuff like that, but only if player positions have been formed by the rules of football. Musicians can remember musical scores wonderfully, you know, very, very easily after a first look at them, especially conductors. They can look at the score and bam, they can remember exactly what's going on, but only if the rules of music, depending on whether it's Western music or whatever, say the rules of Western music were what got the musical, or what constrains, what determines the musical notes and where they exist on the staff. The same with circuit designers, anything. And that's also true of Stephen Poe and other wine experts. So they are great in an experiment where they are shown pairs of words. So for example, full-bodied and prune. So they're asked to memorize pairs of terms or pairs of words that go together, and then to later on recall them. So you know, imagine you're Stephen Poe, you see a list of 100 pairs of words, full-bodied and prune, and other things that go together typically in wine, okay? And then you're asked to recall as many as possible, and Stephen Poe would be so much better than us at doing this. However, if the terms that go together are not sensible given wine sorts of production techniques and that sort of thing, like full-bodied and prune both apply to red wines, lime applies to a white wine, and full body typically doesn't. So if it said full body and lime, as an example, or lime and prune, it makes no sense to him in terms of what he understands in wine production. So he'll be no better at memorizing those terms. All this expertise in visual perception with the chess players or the musicians or the circuit designers, coaches, or flavor perception and remembering how things go together, all that expertise only applies, only works if things are presented in a way that is sensible to what they understand. That enhanced perception is only usable if it's in the context of what makes sense to them, which is interesting. Finally, last minute, I'll be talking about this. And this has to do with something called the verbal overshadowing effect. It's the last part of the slide. What is verbal overshadowing? I'm going to give you a little kind of striking example of what the verbal overshadowing effect is. It's a story about me. It happened a long time ago, but this is it. It's a little, you know, scary, but everything worked out in the end. I was going out to a restaurant with my friend, and we get out of the car. It was kind of a restaurant in kind of in a rural area. We got out of the car, and two guys come over with guns and say, you know, give me your wallets. It was scary. It was definitely scary. And you know, I did. I gave them my wallet. My friend, it was a woman friend. She actually tried to throw her purse into the car, and then, you know, the guy said, do not do that. And she took it out and gave it to him, and they ran away, and that was that. It was shaky. I mean, it was a little scary. But here's the thing I want to kind of convey to you. We then go into the restaurant. They treated us wonderfully. They gave us free meals and everything because we had lost all of our money and everything. They were very kind. The police eventually came, and then they asked for descriptions of the perpetrators. And we started to give descriptions, the best we could, you know, of the, you know, height and, you know, hair length and all that sort of stuff, eye shape and all that stuff. And we did. And they said, okay, well, let me call in my, you know, the other patrols to see if anyone else has seen anybody like that. And in fact, they did. They found these two kind of kids that really kind of fit the description well. So what they did is they put us in the police car, and they drove us to where they had apprehended these guys. They didn't have the wallet on them. They didn't have the purse on them. Okay. But they found these two guys that really fit the description. They did find guns. And they put us in the car, and they do this. It's called a show up sort of rather than a lineup. What they do is they kind of shine the lights, very bright lights, onto the perpetrators, and then ask us, as we're looking at them, they can't see us because of the bright lights. We can see them, whether we are sure these are the people. And both my friend and myself said, boy, I guess they fit the description, but we cannot be 100% sure that it's them. So this is a very common sort of effect. Because my friend and I had given verbal descriptions of what these people look like, what these guys look like, it kind of influenced our ability to recognize them. By the way, the end of the story is the guys were released. We never found our wallets or purse or anything like that. We're fine. We got our credit cards back. Everything worked out fine in the end. The point is that we experienced the verbal overshadowing effect. Okay, our descriptions inhibited our recognition. And this is very true of eyewitnesses describing faces. It's very well known in police investigations that if the witnesses are asked to describe the face, they then become less good at then just plain recognizing the face. It's as if, you know, describing a face changes our memory of the face. You know, we're not great at, by the way, at describing faces to begin with. You know, it's hard for us to describe faces. By the way, there was nobody there drawing it. They were just taking notes, just so you know. But we're not great at describing faces. People just aren't great at describing faces. They're great at recognizing faces, but once they try to describe, it interferes with their ability to recognize. That not only is true of face recognition, it's true of smell and tastes. So if you're tasting a wine and you do your best to describe it, okay, you would be less good at recognizing that wine than if you had never tried to describe it. So you're in an experiment and you're given 5 wines, and you're given one wine. Okay, you're first given one wine. You sip it for a second, you put it down, you describe it the best you can, even though you're an amateur. I wouldn't know to say sauerkraut from yogurt or whatever, but I tried the best I could. And then I'm given 5 wines, and I have to say which one of these 5 wines is the same as that one after I've, that one's put away now. I would be less able to do that because I gave the description. If I had not given the description, I would be better able to do that. So my verbal description overshadows my ability to recognize. So that's true of eyewitnesses, that's true of tastes, it's true of smells, but it's not true. That's true of casual wine drinkers. It's not true of someone like Stephen Poe when it comes to drinking. His ability to methodically describe the wine he tastes, if anything, only enhances his ability to recognize. And that is true not only of Stephen Poe, it's true of any perceptual expert. If a chess playing expert, a chess master, looks at the pieces on the board and describes the pieces on the board, they're very able to then recognize whether that's the same board they saw before. In other words, that's one of the other things that this kind of explicit expertise does to enhance our perception. It has to be, something that kind of follows the rules of wine production and chess and music and all that sort of stuff. But for those folks, because they have developed such a vast language ability and analytical ability with that perceptual skill, it helps them recognize things, unlike the rest of us, where it actually interferes with it. Okay, that does it for taste. Thank you for sticking with us, you 46 folks. Good. Everyone else will have access to this later on. All right, good luck on your exam. I'll be posting things a little bit more over the next few days about the exam on iLearn. See you later.